Hello everyone, my name is Artem Mygaiev. I work in EPAM as a Technology Solutions Director. I'll cover briefly what we've been doing with the community, with Automotive. First time we've been talking about Zen uses in Automotive publicly on XDS in 2013. I know there were some other projects privately in different companies, but I don't think they were covered in XDS before. When we started to talk with automotive industry, with like OEMs like Volvo, Toyota, like big companies who produce cars, they were extremely skeptic about virtualization in general, not about Zen, but about the virtualization as approach. But since then, they changed their mind significantly. There are multiple products that are using hypervisors. And some of the OEMs and tier ones in automotive industry are really interested to increase the stake of open source where possible. But right now, the situation is that still most probably the new product will come up with a proprietary solution. And there are good reasons for that, mostly for the safety and from the safety aspect, somebody has to be responsible, somebody has to take the responsibility for a product and so on and so forth. Back then, we were thinking of like very simplistic scenario of having a single CPU in-vehicle computer to run infotainment, like the central console with, I don't know, with whatever the multimedia system, and the cluster with gears. I don't know how many of you have cars with a new digital gears, like which is on display. I mean, they're just coming out recently, like for the last couple of years. But since then, this changed significantly. I'll talk about that. When we started to work with on Zen for automotive, there were not enough of functionality. Like we had to extend peripheral support for multimedia. Like there was no PV drivers for multimedia, only like input network and so on. So we were working on that. GPU virtualization, mostly people were not caring about that. Trust execution environment, same. And power and performance as well was not really addressed. And we've been multiple times asked about the functional safety support, and I'll talk about that later. Since then, we did a lot of changes. We added UI-centric, by community, peripheral support, like PV for displays, for sound, for multi-touch interfaces. They're all upstreamed now, part of the Linux kernel and so on. We did a lot of research on how to implement GPU sharing with the high performance results. We did several implementations. All of them, unfortunately, are proprietary because GPU vendors are not really friendly to open up the firmware and the GPU code. But just to give you a metric, right now on one of the automotive SoC, we can get GPU shared between guests safely and securely with 3 to 4% performance drop, which I think is pretty nice. Just recently we finished, or almost finished, adding trust execution environment support. Basically, it's a way, well, that's for ARM processors right now, but it's a way to allow guest domains to talk directly with ARM trust zone without power virtualization or other mechanisms. There's some ongoing work to improve hard and firm real-time scheduling. As you know, there's RTDS, but there are like lots of issues that need to be fixed. For example, time accounting need to be fixed. There are some changes proposed for run state. I know there is some work done for cache coloring. I don't know if it's going to be covered or not on this summit. But there's a lot of things happening. And with most of that, we actually can get Zen to be pretty much deterministic. I mean, it's already can be configured in a very deterministic way, but with that, it can be even better. There are some work also happening for energy-aware scheduling for virtualization. That includes voltage and frequency scaling. That includes, I think on DVFS we had a presentation last year on last XDS. With that, we also need to implement governance on the hypervisor level. We need to add more flexible modes for OPPs and so on. That's also work in progress. And recently, there's been work by Stefanov on implementing DOM zero-less by basically targeting dropping dependency on Linux in DOM zero, which is also not important for automotive cases. Another work we need to do is port XL to some RTOS for non-DOM zero-less scenario. And probably the biggest work we did since showing up the first time Zen in automotive in 6 years ago was extremely huge amount of different talks and presentations for OEMs and tier ones and different industry players to persuade them that it's absolutely possible to use Zen in automotive world. As I said, they are very much skeptic. They are very much, how to say it, reluctant for change, and all that was aiming to educate them how to use open source and how to use it on a lower level. And with that, I must say that we succeeded probably because right now the scenarios that we see in vehicles are very interesting. You've heard all these stories about vehicles getting extremely complex and the safety cases of vehicles, well, like some vehicles being hacked, or like some Teslas not really paying attention to what's happening on the road and hitting the other cars or whatever because of the vision processing not being done correctly and so on and so forth. With that, vehicle manufacturers are trying these days to centralize functions, and instead of having zillions of microcontrollers all over the vehicles, the new generation computers inside vehicles will be extremely powerful and centralized. Well, that's the idea. I don't know if it's going to happen or not, but that's for the next gen cars. And the big idea is that there will be some very powerful unit that will be responsible for the cockpit, which is like big screens for a driver, for a passengers, for rear seat infotainment, and so on. And that they really need to combine in them mission critical stuff. Like, to give you an example, you know the telltales, or they call it like stupid lamps or something. When your engine goes broken, there you have a notification that like running out of oil or whatever. That part of the display is covered by the functional safety requirements, meaning that if it's go broken, that you may actually get you may end up with the troubling yourself or damaging equipment or whatever. Another thing is communication gateway. With the growth of 5G deployments, and there will be 5G deployments, there is a special way to connect cars, well, called V2C, I think it's what V2C, vehicle to cloud, or V2I. So there will be a need to deploy 5G firewalls inside the vehicles because of the security issues and so on. And all the internal buses will have to be somehow routed and brokered, and that's addressed now by the communication gateway concept. And in addition to that, vehicle manufacturers are going more like a traditional computing, where you have a big server which runs multiple services, and services can migrate between the nodes, which is also an interesting concept. So all that brings us internals of vehicle more to what it looks like now in data centers and clouds. We have migrations of services between the vehicle nodes, and also between the cloud and the vehicle. We can do bare metal applications, kind of unikernels. They're all very much interested in VMI, in introspection, mostly because of the security issues. When you release a car and it's running in the wild, it will be there forever, and it's always exposed. So there might be as many complex measures on security as possible. And in addition to that, there is also mixed real-time and non-real-time cases, mixed safety critical, non-safety critical cases, which make it even more complex. But with all that, it's very interesting to see how the industry moves from like pure embedded stuff to more like similar to what you have now in data centers and clouds. With that, we work with several groups within community, different communities. One is Automotive Grade Linux, managed by Linux Foundation. I think Walt Miner is going to be here tomorrow from that group. We released, together with them, with Zen Project and AGL, we released a white paper on the virtualization scenario for automotive last year. We work also with GENIVI Alliance. It's a kind of a driven by industry members, not by Linux Foundation. We are a member of Automotive hypervisor work group over there. We work on the specification. And in both of these groups, there is a big tendency towards standardizing the hypervisor. That's another interesting requirement that's coming from an unexpected side. People want to have a standard set of drivers, or at least the protocols, and they see that Virtio is getting tracked, getting attention as a standard, and they're all requesting Virtio also to be utilized somehow in Zen. We recently been on Android Automotive Bootcamp in California, and Android folks initially were pushing back. They also didn't want to use hypervisors within the automotive systems. Right now they say, hey, hypervisors are nice, we like hypervisor, blah, blah, blah. And they also want to use Virtio for virtualizing Android because they've been doing that for years for mobile devices testing in their own GCP. So Virtio is an issue, and I think we have a work group or work design session. I'm encouraging everybody to participate. A few words about the functional safety. Lars already touched base about that. I don't think that everybody really understands what the functional safety is. I want to cover that a little bit. Safety, as it defined, is a freedom for unacceptable risk or harm. And it's risk is a combination of probability and severity of a harm. And harm is injury to people or damage to equipment or environment. So basically, safety is, I've seen many people who are messing up safety and security. That's completely different topics, and they are addressed in a completely different way. So basically, functional safety is defined by standards, by the standards for industrial groups, for the transportation, for whatever, is absence of unreasonable risk due to hazards caused by malfunctional behavior of the complex electronics. That's a copy, that's a quote from the standard. So what it means that you have a system which has inputs and outputs and some hazards, and it produces predictable outputs despite of the influence of hazards. It's not only defects. There are even like hazards caused by, I don't know, some cosmic ray getting in and flipping the bit, which probability is extremely low, but still it's a probability. And there are a bunch of standards on the functional safety. I will not talk about them in details. Unfortunately, I had to learn about them. Feel sorry about that. But in general, we've been trying to go all these papers and try to understand how Zen, as an open source project, not being designed from day zero for safety applications, how it can be, how it can be certified for safety. And you find ways, like in case of 61508, which is an umbrella standard. It's a so-called compliant, non-compliant development, and it's interesting clause. It means that Zen, nevertheless, is not developed in a way that all these proprietary products are. Still, the amount of rigor applied to the patches that are coming in, amount of rigor applied to design decisions is extremely high and is compliant with the one that's required by these standards. So you can actually compare and map one to another and thus certify Zen for functional safety applications. We recently did analysis of the, well, that's pretty dumb. I mean, it's just static analysis. But the Zen, in terms of quality, is as good as other functional safety compliant products which are proprietary. And just to give you a comparison, we also took, like, just for a reference, we took KVMs, this is part of the kernel responsible for KVM, and the defect density is much, much, much higher there comparing to Zen. But that's just by running few static analysis tools. That was fun. I mean, you may be surprised, maybe not. Yeah, and it's another standard. So as we define the certification path for Zen, we need to close several gaps. We need to improve documentation and testing. And I think that it's not really relevant only for safety. I mean, all the community will benefit if we improve testing and if we improve documentation coverage and somehow make documentation up to date and maintained without significantly increasing burden on maintainers, as Lars pointed out. We need to do some defensive programming techniques, unfortunately. I'll talk about that later. And we also need to support certified tools, which again, I don't think that community cares about at all. So, key things that we need to take care of. In lots of projects, in proprietary ones, when people implement functional safety, they just make it like a formality, just like, okay, screw it, like I have a functional safety in some way. We don't want this to happen. On the other hand, we want to do only meaningful things. We don't want to do meaningless or just to follow letter by letter. We don't want to do that. We don't want to increase the engineering burden a lot. And we actually targeting to improve cases where there is no functional safety requirement in place. We also need to improve quality. We need to ensure that all the community benefits from that. And with that, we have several to-dos. Do we have anybody here who is familiar with the V model, engineering development model? No? Oh, one person. No, two. How come? Okay, yeah, right. So V model is one of the very formally defined models of development when you have like specification on top and then going down on one side to the design, to the actual implementation, and then going back with the verification and validation. And you need to check with every stage and then like fall back if something goes wrong. So basically, in the end, you integrate the whole system and check it against the specification. It's extremely highly formal process and nobody wants to implement it. Everybody hates it, but it's like demanded by multiple standards. We need to somehow implement the documents that will resemble V model-like approach for Zen without actually changing anything in our development process. And on the code side, we need to implement a few things: fault processing, use defensive programming, and overall system determinism. Fault processing. There are two kinds of faults. One is systematic faults, which are, mistakes, bugs, or whatever. You can address them only by using proper design validation and verification. And there are transitional faults, like the ones that I mentioned when you have neutrino or something passing by and flipping your bits in your memory. And with that, you need to implement some sort of a protection against this happening. So you cannot just bug in the code on just each and every case. You need to somehow implement the fault safe state. When something goes wrong, you fall back into that safe state. That's an interesting concept, and I think this can be implemented in Zen without really affecting any existing features and without affecting the code. So, and I think also the non-safety cases can benefit from that. So when you can put there like error processing, you can, without just crashing the system, you can do the actual processing of what have happened. Defensive programming. If you look at the standards, again, as Lars said, we had this exercise of trying to address some most controversial rules of MISRA, like default statement and switch cases. And we've got a very interesting feedback from a community. But in general, if you look at all these standards, they say avoid nasty stuff. And then they say, also, now we define what's nasty. And like dynamic memory allocation, it's like don't do that, never ever. Well, of course, that doesn't work for us. Basically, for us, it means that we will go like, again, in a special group that we've set up. We need to go rule by rule, and for every one that we believe it's meaningful, we decide on that with the community. For every rule that we think it's completely useless for Zen, What we have to do is create a waiver together with assessors and say, yeah, well, there's a good reason why we don't follow this particular rule. So I think this is a doable approach. And determinism is, okay, there's another. Determinism means that you can predict how system operates, or you can predict the time when and the way it reacts on inputs and signals and so on. So there are like things, well, I thought there's a session plan, but I might be wrong. In the design session, there's a talk about the cache coloring. I don't know if it's going to happen or not. Sorry? Okay, please ignore the first line. Okay, but cache coloring is very, very important thing. It can give you a much better cache performance, much better cache operation and predictability of the system behavior in terms of memory access. Real-time schedules, there's a huge amount of fixes that has to be done. Like I mentioned already, time accounting. Right now, the time within Zen also accounted as a time of the guest domain, which is not quite correct. We cannot use Slack from the domains and so on and so forth. And we need to implement full preemption, at least as a config option. I don't really like this idea, but there was the, I think in Zen 4.3, there was a demo done by Sang Boom back then he was from Samsung, and he did the fully preemptive Zen and demonstrated like extremely low latency, interrupt latency time and so on. I think it was on ARM. These patches never were published. Don't know what happened with that work. I think some Samsung abandoned it, but we plan to resurrect this somehow. And again, this may be also useful for non-safety cases of Zen. Need to see. And the workflow, I think Lars also mentioned that a little bit. We need to do some assumptions. We need to define a safety compliant code base. We need to agree on the rules and approach fault processing, determinism, and defensive programming, and we need to improve on documentation and testing. Probably this will be funded and implemented as a side activity and just let community to be reviewed. I don't know. And we need to maintain this process, so it's not like one-time certification, one-time work. It has to be running effort somehow. This will include a lot of paperwork. Again, we don't want to put that burden on the community. This has to be handled by the special interest group that we mentioned. And this has to be done in a collaboration with multiple assessing companies so that we are sure that the work we do is not useless. Basically, yeah, just want to mention one point. Basically, for wide use of Zen in automotive, the safety compliance is probably the only last obstacle. I know that at least 10 huge companies who are making cars, I think all of the biggest in the world, are already using Zen internally for the pilot projects. But they don't use it in the production only because of this functional safety reason. That's all I had for now. Any questions? If for some reason you hate functional safety or you hate all this paperwork or whatever, or vice versa, you like it, I'll be happy to discuss that during the days of summit. Thank you very much.